Okay, so this video aims to serve as your tutorial in answering problem set 5, which is on titration curves. Now, so you have 5 problems here. So 4 of them represent one of the SASB, SBSA, WASB, and WBSA. And the last one is a challenge problem. So it's a diprotic acid. I have an example of it in the worksheet. Now, so kindly check the module for the worksheet. I also provided you a demo file, okay, which you can copy the equation. But for you to further understand it, I will explain how to answer that kind of problem, okay? So this is a demo problem. So I have 10 ml of 0.1 molar HCl was titrated with 0.05 molar NaO. Calculate the pH of the solution when 0.1 ml of the titrant is added incrementally up to 30 ml volume titrant. Okay. So first, you have to identify muna what kind of titration are you doing. Okay. So in this problem, the analyte is HCl and the titrant is NaO. So it's a strong acid, strong base titration. So since you know that that is an SASB titration, remind yourself of the equations needed for the initial, pre-equivalence, equivalence, and the post-equivalence stages. Okay. Another thing, no, after identifying the type of titration, you have to know how much titrant will be needed to neutralize your acid. Why is this important? Kasi, you know, you will be adding 0.1 ml of the titrant incrementally. So ibig sabihin, you have to assign stages to the volume of titrants. No? Why is that important? Kasi iba-iba yung equations natin per stage, right? So it is important for you to know the volume of titrant at equivalence point. Okay, just recall your lecture so that you will know how to get the VTEP or the volume of titrants at equivalence point. And based on this problem, I calculated that the volume of titrant at equivalence point is 20 ml. And now, since this is an SASB titration, I will copy the columns I have here. So, yan. Let me explain first, bakit ganyan. So, first column, second column is about the molarity and the volume of the analyte. Third and fourth is about the molarity and volume of the titrant. Then you have millimoles of the analyte and the titrant, and the V total. So why do we have these 6 columns here? No? Because these are the parameters needed in solving titration problems, right? Sorry, I forgot. Volume total is also necessary. So these 7 columns are needed in solving for the pH of the solution, di ba? So tandaan nyo, for SASB, yung equations dyan, kailangan mo ng millimoles, di ba? Kailangan mo ng volume total. So that's why we have this. So the first thing you want to do is to type in the molarity of the analyte, and it is fixed. So ibig sabihin, hindi yan magbabago. It's always 0.1. For the volume of the analyte, it's also fixed. It's 10 ml all throughout the experiment. For the molarity of titrant, it is also fixed. Okay, so 0.05. Now, for the volume of the titrant, this is the variable. No? So, kumbaga, it changes per 0.1 ml. So, gagawin ko, I will first type 0. And then, after that, I will type in 0.1. And what's next? That is 0.2. However, I will discourage you to type it manually kasi marami yan. What I want you to do is to highlight these cells. Okay, and then, di ba you see this tiny tiny green box here at the bottom right corner of the selection. And when you hover your arrow or your cursor, it turns into a thin cross, right? So I want you to drag that until you see the number on the bottom right indicator tells you that the volume is 30. So drag mo lang siya. So just continue dragging it until you see 30 ml. Okay, so 30 ang Okay, so there you go. So now the volume of titrant is 30. Okay. So as you can see, the Excel automatically uh, plugged in the volume of the titrant per 0.1 increments. Okay. The next one, for the millimoles of the analyte, why millimoles? Millimoles because when you multiply molarity and volume in ml, you get millimoles. Okay, so ito yung MAVA. Ito yung MAVA. And this one is the MTVT. Okay, so MAVA gives you millimoles. So just multiply MA and the VA. So instead of dragging it, pababa, what you can do is to just hover your cursor again to the bottom right corner until your cross turns very thin, and then double click it. So drinag na niya lahat yan. Okay? For the millimoles of the titrant, you have to do the same. Okay, so it's empty VT on the other hand. So this is empty and this is VT. Then hover your cursor again at the bottom right and then double click it. Okay, so automatically, andyan na yung mga millimoles nila. For the volume total, all you have to do is to press equal sign and then add the volume of the analyte and the volume of the titrant. So you just add them. And then double click this again so that the volumes will be added. Just like that. Okay. For the stages, okay, so again, we have 4 stages in SASB of monoprotic acids. No? The 4 stages yan. So we have the initial, pre-equivalence, equivalence, then the post. According to our calculations earlier, the volume of titrant at equivalence point is 20 ml, meaning we need to look for the volume of titrant at 20 ml. Right, so this one. So in 20 ml, so this is equivalence point. So we have to indicate that this is the EP. Another thing that you can notice is that the millimoles of the analyte and the titrant are equal at this point. Galing na. So this is EP, equivalence point. And now, what does it mean? So I'll highlight this muna. So that means that if this is the endpoint, any volume of the titrant greater than 20 will be my post-equivalence point. And any volume of the titrant less than 20 is my pre-equivalence point, right? So you have to label them accordingly so you will not get confused. Any volume below 20 ml will be a post-equivalence point, and any volume less than 20 ml will be the pre-equivalence point. So let me just drag it upwards. Okay. Kindly skip 0 because this is the initial. Okay. I'll assign some colors so that I will not get confused later. So for initial, I colored it blue. For the pre-equivalence point, anong color kaya? Green na lang. At the equivalence point, I colored it as yellow. And at the post-equivalence point, I'll color it as anong color? Gray na lang. Okay. So there you go. I have different colors so that I will be reminded that at each stage, iba-iba yung equation. Now, the question is, what is your equation at the initial stage? Remember, in our initial stage, we say that the concentration of H plus is the concentration of the analyte. Okay. So just press equal sign and then select this. There you go. Now, at the pre-equivalence point, what's our equation to get the H plus? So to get the H plus, the equation there is MAVA minus MTVT over V total, right? So MAVA is this one already. MTVT is this one. So you subtract them, kasi yun yung sabi sa equation, MAVA minus MTVT. And then you divide it by the volume total. Okay. So that means this is our equation for the entire pre-equivalence point. So I will just drag it until the end of the pre-equivalence point. Oops. Right? So that is the pre-equivalence point. Those are the concentrations of H plus. And now, at the equivalence point, what's the concentration of H plus again for SASB titration? It's 1 times 10 raised to negative 7 because the pH there is 7. So kahit hindi mo na i-type, no, you just write here that the pH is 7. So remember, this is the column for the pH. Kahit skip mo na yan. Let me just split the Excel so you can still see the column headers. Okay. Oopsie. There you go. Oops. Okay. So the pH here is 7. So kahit huwag nyo na ilagay yung 1 times 10 raised to negative 7. Okay. So automatic 7 yan. And then at the post-equivalence point, what's our equation? So at the post-equivalence point, what's our equation? So if you check our lesson, the equation there is concentration of OH equals MTVT minus MAVA over V total. Okay. So that means you are not solving for the H plus, rather you are now solving for the OH. So again, what's the equation? It's MTVT minus MAVA over the V total. Oops, I forgot parentheses. Okay. Okay. And divided by, oops, sorry, what's happening? I forgot it to divide by the volume total. Okay, so there you go. Okay, so again, it's MAVA minus MTVT. MTVT minus MAVA over V total. That will give us the concentration of the OH. And this is the equation of the post-equivalence point. So for the entirety of this section, I'll just drag the equation until the last entry. Okay. When you do the SBSA, you're going to do the opposite. You will solve first for the OH and then solve for the H plus later on. Okay. Okay, so now we calculated for the concentrations of H plus and the OH. Next thing we're going to do is to determine the pH. No? So for the pH, it's simple. You just type in equal sign and then minus negative log. Okay, minus log. And then open parenthesis, select the concentration. So according to this, the pH here is 1. Okay. And then I'll just drag this now. Yes, because since we solved for the H plus here, the equation for pH will be the same. So puro H plus lang kasi nasa-solve natin yan. So I'll just drag it now until the equivalence point. Okay. And there you go. So may colors siya. Don't mind the colors na. Okay. So yan yung ating pH at the initial and the pre-equivalence point. And now, at equivalence point, automatically our answer is 7. At the post-equivalence point, what's the equation here? Since you get the OH concentration, if you take its negative log, it's actually POH. No? So to solve for the pH from the POH is 14 minus the POH. Diba? Okay. So we'll do that. So equal sign 14 minus the POH, which is negative log of the OH concentration. Okay. Yes, dalawa yung negative sign dyan. No? Kasi minus negative log. Okay. There you go. So this is the POH. And then you just drag it na lang until the end of the entry. And so yeah, that's it. You have the pH values at different volume of titrants. You have the different concentrations here. Ayan. I'll just affix this color para hindi ako malito din. Okay, there you go. And now, so your next task now is to convert this into graph. Okay, so in converting this into a graph, all you have to do is to go to insert and then select this scatter plot. Okay, so choose the scatter plot with smooth lines. Okay, the scatter and then the one with smooth lines. Okay, so at first it will be blank because you don't have any data here yet. So what I want you to do is to select your data. So press this one. And then you press add. Okay, so add entry. So let's say the series name is the pH. For the x value that pertains to the x-axis of the curve, and what's the x-axis again of a titration curve? It's the volume of the titrant, right? So what you're going to do is you have to select the entire volume of titrant starting from 0 up to 30 ml. Okay, so you have to do that. So from 0 up to 30 ml. Okay, so there you go. There you have it. How about the y-axis values? So for the y-axis values, titration curve, the y-axis is the pH. So press equal sign and then select the entire pH values. So from the start to finish. Okay. Then once you have that, press OK. And then OK ulit. And look, you are now able to produce a titration curve. Ay, sorry, pangit pala yung may dots. Let's change the chart type na lang. Pangit pala yung may dots. So just choose this smooth line without the dots. Okay. Okay, there you go. That's a very beautiful titration curve. So if you want to add chart elements, let's say axis title, okay, and then you can go here, select axis title, vertical and horizontal. On the vertical axis, you have the pH. On the horizontal axis, you have the volume of the titrant, VT. Okay. So ganun lang ka-easy. For the first derivative, how will you do this? Ganito lang. You cannot begin with this column, okay, kasi it's change in slope. So you cannot begin with the first entry. Instead, you have to begin here, okay? So you have to begin here, so second entry. So what did I say? Dati? So pag first derivative is the change in y over the change in x. So what is our y? Our y is the pH. So change in y, so this current pH minus the previous one. So that is the change in y, the current minus the previous one. And then for the change in x, delta y, delta x, so our x is the volume of the titrant, so you get the difference as well, okay? So change in x, the current x minus the previous x. Okay, and then press enter. So that's your first derivative. You have to drag it also. Drag mo lang siya pababa until the end of your data set. Okay, there you go. And then if you want to graph it, okay, so if you want to graph it, all you have to do is go here and just select your chart again, and then go to chart design, okay, and then select data again, just like earlier. Okay, again, just click your chart again and chart design, then select data. So when you select your data, you will add another entry. So let's add another one. And this time, the series name will be the first derivative. For the x-axis value, so it will still be the volume of the titrant. However, instead of starting at 0, I will start at 0.1 until the end, okay? For the y-axis, you will still do the same, but again, instead of starting at the first entry, you will begin at the second entry. So this is the second entry I'm pertaining to, okay? So you just scroll down and then select everything, press shift button so you can highlight everything, okay? Okay, and then press OK, and then OK alert. And now, since we have a very high derivative no, at equivalence point, your chart will look like this now. So it will seem like the question on 14. So in order to to correct the range of the chart, you're going to press right click uh, and then alin dito, the format chart area. So right click format chart area, and then at this option here, chart options, look for the vertical axis. Okay, so again, click this and then the vertical axis. At the last option here, you have this axis option with graph. Go there, and then select this axis option. So in the axis option, you can actually limit the range of the vertical axis. So, you know, pH scale is up to 14 only. So instead of having 40, I'll just type 14 and then press enter. There you go. So we can see again that the pH scale is up to 14, just like the normal. And the first derivative curve was cut. And that's fine lang naman. Okay, that is okay with me. Okay, so the good thing here is that you can see that the first derivative and the inflection point overlaps. Okay, so yan. So maganda kasi when they overlap. That means tama yung calculations natin. Okay, so that's it. No? So now I will share you some tips when dealing with weak acids. No? Okay, so for dealing with weak acid, you just go to the original Excel file and then copy this one. Okay. So, yan. So in dealing with weak acid or weak bases, you will have additional columns, the Ka and the Kb. No? Okay. So Ka and Kb have to be included because, you know, the equations require them. So just like earlier, you do the columns for molarity analyte, volume analyte, molarity titrant, volume titrant, millimoles, and the V total. Okay. So I'm going to do that. No? So you can skip this video if you want. Again, the increments will be 0.1 ml. Okay. Siguro 0.2 na lang. Okay, 0.2 ml. Okay, so I changed the increments to 0.2. And then since I want it up to 30 ml volume, so up to 30 ml volume. So all I have to do is to drag this, highlight them. Whenever I'm highlighting multiple cells, I press shift button. Okay, so press shift button, you will highlight multiple cells. Okay, so you have to drag this, okay, until the volume of titrant is 30. So oopsie, magpass. Oops. Okay, so there you go. You have 30 ml. And then for the millimole analyte, millimole titrant, volume total, we will do the same thing. So multiply MAVA, oops, and then MTVT, MTVT. For the V total, you just add the two volumes. Okay. So volume titrant, volume analyte na. And then you just highlight them all and then double click this button here. So everything or all the cells are applied with the equation we used here. And now for the Ka and the Kb. So for the Ka, it's 1.8 times 10 raised to negative 5. So how will you type it in Excel? This is how you're going to do it. So you press 1.8. And instead of writing times 10 raised to negative 5, you just press E minus 5. Okay. So Excel will automatically convert that into a decimal. So again, instead of typing times 10 raised to negative 5, you just press 1.8, then E, and the exponent, negative 5. So I will just drag it for the entire data. Yan. How about the KB? Remember, I told you that the KB can be calculated by KW over KA. Diba? KW over KA. So what's KW? So it's 1 times 10 raised to negative 14 divided by the Ka. Okay. So again, it's Kw over Ka. How will you type it? So it's 1 e raised to negative 14. So that means 1 times 10 raised to negative 14. And then divide it by your Ka. And then I will just drag it down. Okay. And now you have these columns complete. The next thing you're going to do is to assign the stages. So the endpoint here is still 20 ml. I did not change the volumes naman. So yeah, it's still 20 ml. So I will assign this 0 ml of the titrant as the initial. And 20 ml of the titrant, which is here, is the equivalence point. This one will be the post equivalence. And anything below it will be post. Now for the equivalence point naman, everything above it is pre-equivalence. I just drag it upwards, except for the initial stage. Okay. Change color so you will not get confused. Okay. Kahit siguro dito na lang. Okay. I will use green for this one. For the equivalence point, I'll use a different color, orange, yellow na lang. Equivalence point, let's use orange, and then at the post equivalence point, let's use blue. Okay, so yeah. So I color coded them so I will not get confused now. Now, let's now solve for the H plus. In solving for the H plus, what's the equation at the initial when you have a weak acid strong base titration? It's the square root of Chaka. So how will you type it here? So in typing square root, you just type SQRT, open parenthesis, the Chaka. So what is the concentration of your acid? This one. Okay. What's your Ka? This one. So there you have it. That's the H plus concentration. And that only applies to the initial stage. At pre-equivalence point, what's the equation? It's the Henderson-Hasselbalch. So that's pKa plus log of the conjugate base over the acid. Or in other terms, it's also pKa plus log MAVA minus MTBT over, sorry, it's MTBT over MAVA minus MTBT, okay? So pKa muna. So it's negative log of the Ka. You highlight your Ka plus the logarithm Sorry, pH na pala yun. Okay. So, hindi na pala ma-fill out to. So, diretso pH na pala siya. I just forgot the Henderson-Hasselbalch equation. Okay. So, pH equals pKa. So, that's negative log of the Ka. This is your Ka. And then plus logarithm of the MTVT over MAVA minus MTVT. So sa numerator, yung MTVT, which is our millimoles of the titran. Okay, let me highlight it na para hindi kayo malito. Okay, let me compute again. So negative log of the Ka plus logarithm MTVT divided by MAVA minus MTVT. Close parenthesis. Okay. So that's the pH. pH na yung nakuha natin agad. Okay. I just drag it until the end of the pre-equivalence point. Oops. Let's solve for the pH at the initial. So that's just negative log of the H plus concentration. Okay. Anyway, so next one is the equivalence point. What's our equation at equivalence point? You're actually getting the OH concentration, right? So how do you solve for the OH concentration again? Remember, that's a square root of Ca minus Kb, okay? Square root of Ca minus the concentration of the conjugate base, which we say is equal to the MAVA or MTVT divided by the V total. Okay, so this is the MAVA over the V total times the Kb. So this is our Kb, 5 times 10 raised to, let's see. Okay, so times 5 times 10 raised to negative 10. Okay. Let me just verify saan ako nagkamali. Sorry, mali ako na nasalat. Okay. So there you go. This is the OH concentration. Okay. So again, at equivalence point of the weak acid strong base titration, it's square root of concentration of the conjugate base times the Kb. Okay, Ca minus Kb. So the concentration of the conjugate base is MAVA over V total. And the Kb is already given. It's 5 times 10 raised to negative 10. Sorry, 5.6 times 10 raised to negative 10. So you just take its negative log. By the way, it's POH, no? So what you will type to get the pH is 14 minus negative log of the OH concentration. Okay. There you go. So this is the pH at equivalence point. And now at the post-equivalence point, what's the equation again? It's the same as strong acid, strong base. So the OH is MTVT minus MAVA over B total, right? So it's the same as strong base, strong acid. So MTVT minus MAVA divided by the B total. Okay. So you just drag it down. Okay. And to get their pH, you just take the negative log. Sorry, POH pala dapat. So pH is 14 minus the negative log of that. Okay, so it's pH 10. Right, so double click it and there you have it. You have all the pH values needed in the problem. Okay. I'm thinking, why is this Why is this higher than this one? Anyway, that's probably because of our small x approximation. Anyway, so to get the first derivative, we'll also do the same as the previous one. So we will start at the second entry. So it's change in y. So the change in pH, this minus that, divided by the change in x, which is the volume of titrant. So this, sorry, parenthesis. So this minus that, okay? Those parentheses. And then just drag it. No? So drag mo lang. Double click. There you go. Okay, so next, we have to make a curve. So you have to make a curve. Ayan. So let's make a scatter plot again. This time, yung straight line, yung curved lines lang. Okay. There you have it. Oh, bakit may ganito na? Ano meron? I think Excel recognizes some of the data points. But anyway, let's start from a blank data. So scatter with smooth lines. Just like earlier, go to chart design, select data, add some entry. So this is pH. So for the X values, that's the volume of the titrant. Select everything. Lahat yan. And then for the Y-axis, it's the pH. No? So you begin here and then select everything down, press shift so that you can select all the cells. I may want to add the first derivative also. So first derivative. So for the X value is still the volume of titrant. Okay, so go up. Then select the entire volume of the titrant. There you go. And for the Y-axis, just select the first derivative data. Oops, sorry. I forgot to mention na you should not start at 0 pala at first derivative. No? I'll change this to 6. Anyway, let me select this moment. It's kind of stubborn. Yeah. So I'll just change this to 6. Oops. Oh, nagulo na. So I'll delete everything. So again, you should not begin at 0, rather on the first entry below it. Okay, so yeah, and then press OK. And another OK. And there you have it. You have the curves. Yan. Okay. So this is a weak acid, strong base titration. Okay. And you can add other chart entries. So you just add titles if you want. If you want to adjust the vertical axis, that's fine as well. Okay, as long as you do it correctly. And then that's it.